our warm-ups today, we want to solve -3 times 200 times 17 times 0 times -5. What's the answer going to be, Jaquan? It's going to be 0. So anything times 0 is going to be 0. So we put a lot of numbers in there. We didn't have to do any real work. On number 2, what property are we using? Distributive property. So I'm going to distribute that -5 to both of these. Okay, so when we do this, we have -5 times x, which gives me -5x. And then -5 times -8. Yep, plus 40. Nice job, you guys. Okay, and then after that, we got 2 times. We're going to do that distributive property. So our first one, we have 3 times -u. What does that give me? -3u. 3 times -5. -15. Then we have a -8 times 2u. -16u. -8 times 1. -8. Okay, we're going to combine like terms. Like terms are things that have the same variable or no variable at all. We see we have 2 terms that have u, so -3 minus 16u gives me -19u. Thank you. And then -15, it's a sad looking 15, but it's a 15. -15 minus 8. -23. So be careful there with the negatives. We have 2 negatives, so -15 minus 8. And so it's going to become further away from 0, a bigger negative number. Today we're talking about linear pairs and vertical angles. It's section 2.4 in your book. And our objective that you're writing at the top of your page is to be able to find the measure of an angle formed by intersecting lines. So find the measure of an angle formed by intersecting lines. So our definitions, our first one is a vertical angle. 2 angles that are not adjacent and whose sides are formed by 2 intersecting lines, vertical angles. I'll draw a picture for this after you have time to write it. And the other one is linear pairs. 2 adjacent angles whose non-common sides are on the same line. So I had to finish that definition out. It didn't type out. On the same line. I'll draw both of those in 1 minute. So our first ones, we're talking about vertical angles. So vertical angles are 2 angles that are not adjacent who are formed by lines that are intersecting. So the non-adjacent angles in this case, we see that 1 and 3 are vertical angles. They're directly across from each other, 1 and 3. So I can say angle 1 and angle 3 are vertical angles. Okay, what other ones would be vertical angles? Yep, 2 and 4. 4 are also vertical angles. Okay, so I have another teacher that talked to me about how she teaches this. And when she teaches it as 2 fish kissing. She told me she thinks that sometimes that visual helps students. So if that was the case, you could see that you had a fish here. Well, kind of. And a fish here. Try that again, Jenkins. And then she has the little eyes. And you see that when the 2 fish kiss, can you see the fish there? Little eyeballs. Then you have the little gills. And then you have the fins. So when they kiss, you have the kissing fish. It's going to be vertical angles. Down below we have linear pairs. These are 2 adjacent angles. What does it mean to be adjacent? Next to, yep. Next to, same vertex, 1 shared side. So we have 2 adjacent angles whose non-shared sides lie on the same line. So we see that 1 and 2, angles 1 and angle 2, are linear pairs. Which other ones are linear pairs? We have 3 other options. There are quite a few on this one. So we can also say that 2 and 3 are linear pairs. Non-shared sides lie on the same line. We can say 3 and 4. We can say 4 and 1. All of them are going to be linear pairs. Nice job. Say it one more time. It's the adjacent angle that where the other, like half of it, the other sides, lie on the same line. So it's going to form a line with it. So, yep, adjacent angles as long as they share that non-common side is on the same line. Today we're going to talk about the postulate of if 2 angles form a linear pair, then they are supplementary. What does it mean to be supplementary? 180. Nice job. For this example, we want to determine whether the angles are vertical, linear pairs, or neither. So right here, we see we have angle 1 and 2. Which one do you think this is going to be? It's going to be a linear pair, right? Shared vertex, common side, so they're adjacent. The non-common sides lie on the same line. We see that it's a linear pair. Okay, I'm going to skip B for a second. We're going to go on to C. On C, what do you think these are going to be? We're looking at angles 5 and 6. They're vertical. How did you know that? So not adjacent. They're both opposite, right? So, yep, they're vertical, and you knew why. You just had to flip the words. So we see that they're both opposite of each other. Those little kissy fishes are kissing right here. So we see 5 and 6 are going to be vertical. So what's the difference between B and C? What's the difference between B and C? Do we think 3 and 4 are going to be linear pairs, vertical angles, or neither? And how do you guys know that? I agree with you. So the reason we're able to see that is we have one straight line, right? And then it's being intersected by 2 rays. This is not a line in itself. It's 2 separate rays, so they are not going to be forming it. It has to be 2 intersecting lines or 2 or more intersecting lines. So over here, we want to find the measure of angle CDF. Okay? What is the relationship happening between these 2 angles? They're going to be supplementary because you know that they are. What was the new word that we talked about? Linear pairs. Yep, so linear pairs are supplementary. So we say they're linear pairs. What does it mean to be supplementary? Equals 180. Yep. So we take 180. We're going to subtract the angle we have, 107, and we're going to solve. How much is that one going to be?
What I look like 27.
The answer was 73 degrees. So next one up, we have example 3. Example 3 is going to be 2 lines intersecting. We're here and we have J. We have 115. And we have H, K, J, L, M. My J looks kind of like a 5, so I'll fix that. We're here. We want to find the measure of angle HJK. We only have the measure of 115 degrees for angle measure MJL. We have a relationship here. How do I find this angle measure? What's the relationship between this angle here and this angle here? So we don't know for sure that they're the same, but we know that they are linear pairs. So we're going to look here and we're going to see we're going to have 180 minus 15. Natalie, you're just getting a step a little bit ahead. So when we do that, 180 minus 115? 65? Okay. If we're going over here, what's the relationship between these 2 angles? What are they? They're linear pairs, and we already did that work. So you know how much is it? 65. It's 65 because we already did the work over there. I'll still show it. But we already did that work. Okay, so how do I find the measure of angle J? Yes, ma'am? Yep, we can subtract 65 from 180 because now we have linear pairs going the other direction. And what value do we get? I heard you say it. 115. Okay, so this is what I think Natalie was saying a second ago. So what are our relationships here? What do you see about these measures? Vertical angles are, I heard say, the same. They're congruent. So we see vertical angles are congruent. Each of the vertical angles have that same measure. So I put a little note on my page right here, and I wrote vertical angles are congruent. So we see that we have 35 degrees here. Are these going to be references to which angle we're talking about? Are they the number of degrees inside that angle? When we see 1, 2, and 3, are they references to a specific angle, or are they telling us the degrees? So they're references to the specific angle, right? So we're talking about angle 1. How can we find the measure of angle 1? What's the relationship between these two? They're linear pairs. So we're going to do 180 minus 35, which equals 145. Okay, so if we know this angle is 145, what does this angle have to be? We have to know it's 145 too because they're vertical angles. And then my last one we are going to find right here, what's this one going to have to be? 35 because they are, once again, vertical angles. On our second one, we had to still find that relationship. So what's the relationship between 1 and our 77 degrees? They're linear pairs, so I do 180 minus 77, which gives you 103 degrees. Okay, angles opposite of each other are vertical, so what's angle 3 going to be? 103 degrees. And angle 2 is going to be 77 degrees. So when we're looking for this, we want to solve the value of x. What's the relationship between the two angles we have? Oh, I heard somebody say it. What are they? Maybe I'm not hearing it. What's this relationship? They're kissy fish. What does that mean? They're vertical angles. So when they have that, when they're opposite sides, we see they're vertical, and vertical angles are congruent. So we can set those equal to each other. So I have 4x minus 42 equals 2x. I got to combine those like terms. Like terms are the same, they have the same variable or don't have a variable at all. So in this case, what's my first step? So either one of those would have worked. I just heard more people say subtract 4x. But if you want to subtract 42, well, we'd add 42. It'd just be a one more step, but that's not a big deal at all. But if we subtract the 4x, it's just a little bit less work. We end up with negative 42 equals 2x minus 4x. Negative, exactly right. Negative 2x, we want to get x by itself. What do? Divide by that negative 2. X equals 21. Okay, on the next one, what's the relationship between these two angles? What's our relationship there? They're going to be congruent because they are vertical. So we see that we have 113x plus 16 equals 14x plus 7. We want to get our like terms together. Again, those are things with variables. And then we have the things without variables that are also like terms. So what's our first step? Subtract 7. Okay. I'm showed in 2 steps. So we see we have 3x. Let's try it again. Plus 9 equals 14x. I gotta get those x's together. How do I do it? Yep, we're going to subtract that 13x. Nice job, guys. And then I'm left with 9 equals x.